Today we're going to look at simplifying expressions with rational exponents. We've done this with integer exponents, but now we're going to look at those rationals. Remember, rationals means our good old friends, fractions. So we're going to look at fractional exponents and being able to simplify things with those. So we're going to start off with reviewing those exponent rules, and then we're going to look at a few examples. So let's go ahead and review those rules. Remember, if I give you a to the m times a to the n, that's the same as adding those two exponents, and our base is going to stay the same. So I have a to the m plus n. If I gave you a to the m to the n power, here I'm going to multiply my two exponents together, so I have a to the mn. If I have two bases to the same power, I can break this up by distributing this exponent to both of my exponents by multiplying. So I have a to the m and b to the m. Remember my negative exponents. If I have a to the negative m, I can rewrite this as 1 over a to the positive m. Likewise, if I have 1 over a to the negative m, I can rewrite this as a to the positive m. We can also look at a to the m divided by a to the n. Here, if my bases are the same, I can subtract my exponents. So I have a to the m minus n. Remember, however, we always take the larger number minus the smaller number, and that's where it goes. So, in this case, I would say that m was larger than n because I took m minus n. So a quick example of that, remember if I have a to the fourth over a squared. Here I'm going to go ahead and subtract 4 minus 2, which gives me a squared. But if I had a squared over a to the fourth, now my larger exponent's on the bottom, so I'm going to relieve that exponent on the bottom. So I have a to the second under my 1. We also had a fraction to an exponent, and we were able to distribute this m to both of my exponents. So I have a to the m over b to the m. And finally, any base to the 0 power gives me the value of 1. Remember, these should all be the rules that we talked about at the beginning of our radical lesson. So let's go ahead and use those rules with our rational exponents. So let's look at example 1. And in example 1, let's take the quantity of x to the negative 4/7 to the 7th power. Here, we can go ahead and multiply our negative 4/7 to 7, and we end up with x to the negative 4th. We end up with a negative exponent, so we can rewrite this as a positive exponent as 1 over x to the 4th. We can't simplify this anymore, so there's our final answer for example 1. In example 2, let's get a little more complicated, and we're going to throw x to the 2/3 times y to the negative 1/6 all to the negative 12th. Here what I'd like to do is multiply this negative 12 to 2/3 and negative 12 to the negative 1/6. Since our denominator is not the same as our numerator, we can go ahead and write this as a fraction. And remember, when we multiply fractions, we're actually going to multiply the top two numbers together and multiply the bottom two numbers together. So this is going to look like x to the negative 24/3 and y to the positive 12/6. Simplifying this, negative 24 over 3 is negative 8, and 12 divided by 6 is 2. If I look at my negative exponent, I can take this to the bottom. Remember my y squared, if I have a positive exponent, we're not going to move that. So we end up with y squared over x to the 8th. Since we don't have common bases, there's our final answer. In example 3, we're going to get just a little more complicated, like I always like to do. So we have x to the 1/2 times x to the 5/12, all to the 1/3 power. And then we're going to throw this division sign in there, and we're going to take x to the 2/3. So now we got to use those exponent rules that we learned before. Here we can go ahead and simplify inside this quantity first. If I have x to the 1/2 times x to the 5/12, remember I can add these two exponents together. In order to add fractions, I need a common denominator. And my common denominator would be 12, and 1/2 is the same as 6/12. So now I have x to the 6/12 times x to the 5/12. Now I can go ahead and add my two exponents, and I end up with x to the 11/12. And this is to the 1/3 power divided by x to the 2/3 power. Now I have an exponent to an exponent, so I can clean up this first part as x to the 11 over 36. Remember, we're going to multiply these two exponents together. I'm going to divide this. We really don't like that division sign, so we're going to write it as a line on top of that, or over that x to the 11/36, and we get x to 2/3 as our denominator. Now we can go ahead and think of x to the 11/36 and x to the 2/3. Since I have a common base, I can go ahead and subtract these two exponents. You may be asking yourself, well, how do I know which one's larger? Well, let's go ahead and find a common denominator, since we're going to subtract them anyway, and that'll give us a better idea. So we have x to the 11/36. Common denominator is going to be 36, since 3 goes into 36. So writing this as a common denominator, we multiply the 3 by 12 to get 36. So we're going to multiply the 2 by 12 and get 24. Now it should be pretty clear that our denominator is larger, has a larger exponent than a numerator. So we're going to go ahead and subtract those two. Since my answer or my term is going to be on the bottom of my fraction, I'm going to put a 1 in the numerator's place to hold its value. And we're going to take 24 minus 11, gives us 13, and our denominator is going to stay the same. So our final answer is 1 over x to the 13 over 36. In example 4, we even get a little more crazy. Let's throw some numbers at you. So let's take 16, say, to the negative first. And let's take x to the 14th. And let's divide that by 81, y to the negative 18th. And let's take all of this to the 1/2 power. How beautiful is that? Well, there's a couple of things that we can look at this and say, well, we have this negative power, which can take it to the bottom, and we have this y to the negative 18th power, which is going to bring it to the top. So rewriting this with all positive exponents, I have x to the 14th, I have y to the 18th in my numerator, and my denominator I have 16 times 81. And this is all to the 1/2 power. Now we could go ahead and take 16 and 81 and multiply those together and get a very large number. How many of you want to do that? Oh, nobody. Well, let's go ahead then and work it with just 16 times 81. So remember, if I have an exponent to an exponent and I have fractions, I can take this 1/2 and multiply it to each of my exponents. So 14 times 1/2 gives me 7. 18 times 1/2 gives me 9. Now on the bottom, I have 16, this is to the first, and 81 is to the first. So 1 times 1/2 gives me 16 to the 1/2, and I get 81 to the 1/2. Now if we think 16 to the 1/2, we should remember that to the 1/2 power simply means the square root. So I'm looking at the square root of 16, which is 4, and the square root of 81, which is 9. Now I can take 4 times 9, multiply it together, and get 36. So my final answer will be x to the 7th, y to the 9th, divided by 36. See how much easier it was to work with those smaller numbers instead of trying to multiply at 16 and at 81 together. In example 5, we're going to throw some brackets at you. So let's say I have, oh, you can't see that. There we go. Let's say we have the quantity of the quantity, x to the negative 1/3, all to the 3rd power, and then that quantity and take it to the 1/4 power. How would we go about solving this? Well, just like in an equation, we go into the brackets first, and we go as deep as we possibly can. So here, I have x to the negative 1/3 to the 3rd power. I would go ahead and multiply these two exponents together since I have an exponent to an exponent. So I can write this as x negative 1/3 times 3 gives me negative 1, and that's going to be to the 1/4 power still. Two things I can do from here. I can make this negative exponent positive by making it 1 over x, or I can go ahead and multiply these together. Doesn't really matter which one we choose to do first. So let's take and multiply them. Negative 1 times 1/4 gives us negative 1/4. We still have that negative exponent, so remove it to the bottom, and we end up with 1 over x to the 1/4. Now if we were to go ahead and simplify that first, here's another avenue that we could see this problem. So we can see it as 1 over x to the 1/4 power. 1 to the 1/4, well, 1 to any power is going to be 1, and then multiplying x to the first, 1 times 1/4 gives us x to the 1/4. So notice how we have the same answer, doesn't matter how we got there. And that'll be our final answer. Continuing with the theme of today, let's get a little more nasty. So we have x to the 1/5. Let's take y to the 3/2, and let's divide this by x to the negative 1/2 and y to the 3/4. And let's take all of this to the 1st power. Now again, there's a couple of things that we can do. Hopefully, we see this negative 1. Well, what's a negative 1 going to do? That negative 1 is going to switch all of these exponents. Well, what does that tell us to do? We're going to end up flipping all of these terms. So hopefully, with our rules of exponents, we can simply see this as x to the negative 1/2, y to the 3/4 over x to the 1/5, y to the 3/2. Notice my numerator became my denominator, and my denominator became the numerator. Anything to the 1st power is going to be itself, so that's going to be simplified at this point. And we've gotten rid of that negative 1st power. Now we can continue looking at our negative exponent. We still have one, so we can go ahead and move that to the bottom. So we have y to the 3/4 over x to the 1/2, x to the 1/5, and y to the 3/2 power. Now all we need to do is simplify our x's and our y's. Well, remember, if they're being multiplied together, looking at the x's, we can go ahead and add these two exponents. To add 1/2 to 1/5 off to the side here, remember we need a common denominator between 2 and 5. That's going to be 10. We multiply the 2 by 5, so we multiply the 1 by 5. We multiply the 5 by 2 to get 10, so we multiply the 1 by 2 and get 10. So we'll end up with 7 tenths. Since our x's started on the bottom, they're going to finish up on the bottom as well. Now if we look at our y's, we have 3/4 and we have 3/2. At this point, we should know that 3/2 is larger than 3/4. So I'm going to take 3/2 and subtract 3/4. Getting my common denominator, which is going to be 4. I multiply the 2 by 2 to get 4. So I end up with 6. 3 times 2 gives me 6. Minus 3, since I already have a common denominator. And I end up with 3/4. We have more on the bottom, or larger exponents on the bottom. So we're going to put that on the bottom. Well, what do we put on the top? Well, since everything's canceled out, we're going to make sure we have a placeholder there, and we're going to put the 1. And there's our final answer. 1 over x to the 7/10, y to the 3/4. Let's go ahead and look. Wow, we're on a roll. How about example 7? Here, let's take negative 32, x to the negative 10th, y to the 15th, all to the 1/5 power. Here, again, we have a couple things we can do. We could multiply this 1/5 in to our exponents, or we could take care of the negative exponent. What I would suggest that we do is go ahead and multiply that 1/5 through, since these two exponents are already divisible by that 5. So we'll have negative 32 to the 1/5 power. We have x, negative 10 times 1/5 gives us negative 2. And 15 times 1/5 gives us 3. Now we can go ahead and start working with each term individually. So we have negative 32 to the 1/5 power. Remember, this means the 5th root of negative 32. And hopefully remember the 5th root of negative 32 is negative 2. If not, let's go back and review those exponents that I gave you several lessons ago. If we have x to the negative 2nd, we can make that positive by taking it to the bottom of our fraction. Remember, we only move the base that has the negative exponent. So we're going to end up with an x to the 2nd on the bottom. Our y to the 3rd is still positive, so we'll have our y to the 3rd on the top. And that's going to be our final answer. Negative 2y to the 3rd over x squared. And how about, oh, give me one more. Sure, I will. Example 8. And let's go ahead and look at 81 y to the negative 16th over 16 x to the 12th, all to the 1/4 power. In this example, again, we have a negative exponent in there, so we could bring it down, or we could take the 1/4 through to each of my exponents. Doesn't really matter which one you want to do. So let's go ahead and multiply that 1/4 through. So we have 81 to the 1/4. Y, negative 16 times 1/4 is negative 4 over 16 to the 1/4 power. And then 12 times 1/4 gives us 3. Now we can start simplifying each of these individual pieces. 81 to the 1/4 is 3. Y to the negative 4th is going to go to the bottom. So we have 3 over 16 to the 1/4 is 2. We have x to the 3rd down there, and our y to the negative 4th came down, so we're going to write it as y to the 4th, and we have a positive exponent. And there's our final answer. So let's go ahead and review fairly quickly. We simply looked at reviewing the rules of our exponents, and then we started in at simplifying using those rules. And that concludes our examples.